Okay, so I'm going to make a review, a video of the review for the performance assessment. I pre-wrote out the first part because I just wanted to talk about it, the method for doing the density of an irregular shaped object. So basically, what you're doing is you're taking a graduated cylinder with enough water to cover the object. You're dropping the object in. That way you have an initial volume and a final volume. You're subtracting the initial volume from the final volume. That gives you the volume of the actual character. So what they told you is that I started with a graduated cylinder that had 100 milliliters of water in it. I dropped in the character and the water level went up to 118. If I subtract the initial volume measurement from the final volume measurement, 100 or 118 minus 100, that means that the volume of the character is 18 milliliters. That's what all this writing was for. And then once I have a volume of 18 milliliters and a mass of 23 grams, I know how to find the density. Density is just mass over volume. So 23 divided by 18 is 1.27 grams per milliliter. Don't forget units. Units are going to be important on tomorrow's performance exam. We're going to need to see units for everything, right? Right. Okay, so I wrote all that out. Hopefully you can see that and read that. Should I read it? Yeah, I guess I will. In a graduated cylinder with enough water to cover my irregular shaped object, the Lego character, I would take an initial volume measurement, 100 milliliters. I would then put the character into the graduated cylinder and take a volume measurement, 118 milliliters. I would subtract the initial volume, 100, from the final volume, 118, to obtain the volume of the character, 18 milliliters. With a volume of 18 milliliters and a mass of 23 grams, I would then calculate density. That's pretty much all you're doing for this thing. Based on a chart below, if a sample of metal has a mass of 420 grams and a volume of 40 milliliters, which metal below is most likely? So whether you use the triangle, where you know that mass equals density times volume, or whether you use the classic density equals mass over volume. However you want to calculate this, but 420 grams over 40 milliliters. Let's just do 420 divided by 40 equals 10.5. That's silver. That is silver. So this equals a density of 10.5 grams per milliliter. And the only one on here near that is silver, so that is silver. So I've identified. Okay, now the part I have a problem with. So I'm going to do this sheet. We're going to work through this. Sulfur's atomic number. If I look at the periodic table, sulfur is 16. The atomic mass comes off the periodic table, and sulfur is 32.1. The number of protons is 16. Remember, A equals P equals E, so A equals P equals E. Number of neutrons. So the most abundant isotope of this is sulfur 32. So if I take 32 and subtract 16 protons, I get 16 neutrons, right? Okay, now this part where it's asking whether it's an element, an ion, or an isotope. Well, sulfur 32 is definitely an isotope. Sulfur is definitely an element. And since I have the same number of electrons as protons, it is not an ion. So it is an element and an isotope. By the way, each of these things is an element and an isotope. Okay, number of protons, 35. That means its atomic number is 35. That means it is bromine. Bromine. And because it's got one more electron than protons, I know that it's charged -1. Its atomic mass, bromine, is 79.9. The number of neutrons, well, if I take the most common isotope of bromine, which is bromine 80, it would be 80 minus 35. 80 minus 35 equals 45. So this has 45 neutrons. And again, bromine is an isotope. Bromine 80 is bromine is an element. Bromine 80 is an isotope. And because it does have a differing number of electrons and protons, it is an ion as well. That is the only ion out of these four. The rest are elements and isotopes. 63.546, so I'm going to find that mass here, 63.546, so copper. Its atomic number is 29, straight off the periodic table. Its number of protons is 29, its number of electrons is 29, and if I take the most abundant kind of copper, which is copper 64, clear. 64 minus 29 equals 35. And this bottom one, number of protons 15, that means its atomic number is 15. That means it is atomic number 15, so it is phosphorus. And that means its atomic mass is 31.0. That means the number of electrons is 15. Oh, wait. So they gave me neutrons and they didn't tell me my mass number, which would obviously be 33. So this is phosphorus. Phosphorus 33. And its atomic mass is still the same because that still comes off the periodic table. Now its mass number is 33, but again, I don't really like how this table is set up. It's not set up real great. Really, they should, I don't know, differentiate that for you. But anyway, that's all the answers for there. Okay, a lot of people had problems with this one. It's basically figuring out what the rules are for metals, or properties are for metals, nonmetals, and metalloids, and seeing which one of these is which. Okay. So you're fine. All right. Determine what type of elements the unknowns are. Okay, so if it conducts electricity, copper conducts electricity because that's what they make wires out of. Is it malleable? Copper is malleable and it's a metal. Is it shiny? Copper is shiny. Does it react with acid? Magnesium reacts with acid and it's a metal. So these are all metals, properties of metals. Their oxidation numbers are positive. And now I'm going to do the bottom one. Conducts electricity, no. Brittle, dull, does not react. That would be a nonmetal, the exact opposite of a metal. And if it has properties of both, like this has properties of metal, properties of nonmetal, properties of metal, properties of nonmetal. So it is a metalloid. Metalloid, see, because it doesn't react with acid, just like it's a nonmetal, but it's shiny like a metal. It's brittle like a nonmetal, but it conducts electricity like a metal, so it's a metalloid. Metalloids can have plus or minus oxidation numbers because they are right here. So boron has a +3, silicon has a +4, -4. Nonmetals have minuses, negative oxidation numbers. Now, this last one, oxidation or atomic number 117. Luckily, the periodic table is periodic in that it just counts. 109, 110, 111, 112, 113, 14, 15, 16, 17. So this phantom element, element 117, exists right here. And what do I know about things that exist right here? Well, I know it's a halogen, which is a nonmetal. I know that it would have negative oxidation number, -1 to be exact, -1 because it's right down here. And I also know that it's going to have all the characteristics of nonmetals, so it's not going to conduct electricity. It's going to be brittle. It's going to be dull. It's not going to react with acid because it's a nonmetal. That's what they're looking for here. Element 117. You can do that with any element. I could do that with element 70. Just look where it is. Okay, listen, 70 is not a good choice, but 75. Look where it is and tell me all about it, right? All right, let's keep on hammering through. Formula for sodium phosphate. Okay, so I know that it's Na. And I know that a phosphate is a PO4, and that it is -3 and +1, and I crisscross, so I have Na3PO4, cobalt to chlorate. So I have cobalt, and I have a chlorate, ClO3, and then a chlorate is charged -1, and that cobalt in this case is charged +2, so I know I have 2 of these ClO3 groups. Okay, calcium fluoride, Ca, and fluorine, and calcium is +2. Fluorine is -1, so CaF2. Lead-3 nitrate, so I have Pb. I have a nitrate, so nitrate is right here. It is NO3, it is -1. NO3 -1 +3. You know where I got that +3, right? +3. Same place I got that +2 off of cobalt. +2. That's what the Roman numeral is there for. Now, if you don't crisscross, then you are not done. This 3 does not drop straight down to lead. This 3 crisscrosses so that I have 3 nitrates and 1 lead. Make sure you crisscross. Oh my gosh, just crisscross to get a formula. All right, aluminum phosphide. So I have aluminum and phosphorus, which turns into a phosphide. Aluminum is +3, phosphide is -3. Aluminum +3, phosphide -3. So they cancel, so it's just ALP. Now then, we're going to name some things. The first thing you have to name, we have to know if it's ionic or covalent. Luckily, they've given us just all ionics here, so we're just magnesium bromide. Do I need a Roman numeral? Well, let's see where magnesium is. Magnesium's right here on the periodic table. That has a definite oxidation state of +2, so I do not need a Roman numeral in the middle of this. Lithium and a perchlorate, ClO4. So ClO4, perchlorate, ClO4, perchlorates. So I have a lithium perchlorate. Do I need a Roman numeral? Lithium has a definite oxidation number of +1, so I do not need a Roman numeral. BaO, barium oxide. Barium is right here, has a definite oxidation number, so I don't need to, oh, what did I do? I skipped down one. How did I do that? Barium oxide is one down. Barium oxide. Okay, NH4PO3, so I now have ammonium. And now I got to find a PO3 on the back of here. So PO3 phosphate. And no Roman numeral needed. And 10. What is the charge of 10? Right here it's actually, that would be +4. So that would be 10. 4. I told you I wouldn't do anything where you would have to take out the greatest common factor, but in this case you do. The 10 and the oxygen -2 +4, crisscross 4 and 2, factor out of 2. So that's how that works. 10 is +4, oxygen is -2, crisscross, that would be SN2O4, and then factor out a greatest common factor, which is 2, factor out that 2, that means SnO2. Remember that 10 is one of the 3, 10, lead, bismuth, that have multiple oxidation states, even though they're in areas where they look like they should have one oxidation state. 10, lead, and bismuth. All right, let's keep going. All right, lanthanide. So this is lanthanides, this is actinides. So lanthanide is H. Alkali earth metal is B. Halogen is G. Metalloid is E. Actinide is I. Nonmetal, F, G, or J. Those are all three nonmetals. Noble gas is J. Transition metal is C. Period 5 element. 1, 2, 3, 4, 5. D. D. Alkali metal is A. That's just something you're going to have to know, or go back to your periodic table that you colored in. Alkali metals, alkali earth metals, transition metals, boron group, carbon group, nitrogen group, oxygen group, halogens, noble gases, lanthanides, actinides, right? Okay, now then, what would have a greater electronegativity, D or E? All right, there's D and there's E, and electronegativity goes up to here, not including these things here. So E would clearly have the greater electronegativity. Greater ionization energy, A or G? So G or A? G is definitely, again, because ionization energy has the same periodic trend up and to the right. So G is going to have the greater ionization energy. Smaller atomic radii, C or F? C or F. Atomic radii goes the opposite direction. So C is going to be bigger than F, so F has the smaller atomic radii. Remember the trend. Remember our trend. So I'm going to draw a series of periodic tables here. Ionization, energy, and let's just do it. Let's just draw 4 of them, shall we? Nah, we don't want to draw 4, do we? I'm going to do electronegativity. Reactivity, remember there are 2 for reactivity. And atomic radii. So the increasing trend for atomic radii is down and to the left. For reactivity is down and to the left and up and to the right, not including noble gases. For electronegativity, it's up and to the right, not including noble gases. And for ionization energy, it's up and to the right. Okay. And we answered all these. C and F, between smaller atomic radii, C and F. Here's C, here's F. Atomic radii goes down and to the left, so this one is bigger than this one. Therefore, F is smaller, F. Which letter would have 7 valence electrons? That would be group 17, right? Because that's the dead giveaway. 6, 5, 4, 3, 2, 1. Or group 3A, 4A, 5A, 6A, 7A, or G. G has 7 valence electrons. Which letter would be the most reactive metal? That would be A, because remember reactivity in metals goes down and to the left. That is the farthest left and farthest down metal. A. Which letter would be the most reactive nonmetal? That would be F. No, G. That would be G. Because it would be the farthest right and closest to the top to fluorine, so it would be this one. I said F because fluorine is the letter F. It belongs right here, and that would be the most reactive nonmetal, but they mess you up by putting an F on here, and the F is actually, fluorine is up there. Is metal C a metal, nonmetal, or metalloid? Metal C is right here. It is definitely a metal. Everything to the left of this staircase is a metal. And what energy level is D? A lot of people miss this one. And what energy level is D? Remember, these are called shells or energy levels or periods. Shells, energy levels, also called periods. I see D, 5. It's in energy level 5. 5, 6, 7. What is the oxidation number of F? F is right here. That's in group 16. Go to group 16, -2. A lot of people have been messing up valence electrons, oxidation number, and energy level. Energy level is the number of shells, and this definitely D has 5. Oxidation number is definitely these minuses and pluses over our ions here once they become ions. All right, the last push. Let's just try and do it all in one video. Use the table to fill out the answers to the questions below. Is B a cation or an anion? Okay, so we got to go look back at B. B is right here. It is a metal. By definition, all metals are cations. What is the name of the compound formed between the letters B and F? Okay, so now I got to look. B is calcium. And F is not fluorine, it's actually sulfur. So this would be calcium sulfide. Organize the following elements in order of smallest to largest atomic radii. Okay, well, we know where the trend goes. The trend goes down and to the left. Ba, Mg, Ca. Mg, Ca, Ba. So from smallest to largest. So this is the smallest. Ca is the next. Ba is the largest. Remember, the trend goes down and to the left. So anything in a line is going to be Mg, Ca, Ba. Mg, Ca, Ba. Smallest to largest. Done. Okay, a technician recorded data for properties of period 3 elements. So this is all the properties. After reviewing the data, what family of elements would you expect a new element to belong to if it has an atomic size of 118, reacts slowly with cold water, and is a gas at room temperature? Well, it reacts slowly with water, and it's a gas at room temperature. And if you look at the periodic table, gases at room temperatures are these things, and that's it. So I'm going to say it's a halogen. Because it reacts slowly with water just like chlorine, another halogen. But since it's slightly bigger than chlorine, I'm going to say it's bromine. So chlorine's here, and it has a size of 99 picometers, and this has 118 picometers, so I'm going to go down one layer and say it's bromine. Why? Because you said it reacts slowly with cold water, and there's only one thing that reacts slowly with cold water, and things that react the same are in columns. Okay, is the element a metal, nonmetal, or metalloid? It is a nonmetal. It's a cation or anion? It's an anion because it's an anion. Anion, how do you know? Because it's a nonmetal, and nonmetals form anions. Give the charge formed by the ion. That would be -1 because all halogens are -1. Does the element have an atomic radius smaller or larger than potassium? Well, if it's bromine, here's potassium, here's bromine. The trend goes down and to the left, so potassium is much bigger than bromine. So I'm going to say it is smaller than potassium. When bonded with sodium, does it form an ionic or covalent bond? Well, sodium's a metal, so I can just tell you it's ionic right now. What is the electron config of bromine? All right, so I can do this one of two ways. I can write the off bow. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. But I'm just going to go through the off bow the way I know it goes and gets to bromine. So I have 35 electrons to account for. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. That is the electron config for bromine. Well, let's see if I did this right. 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 35 electrons. It is bromine. I've done it correctly. I do it by going through the chart. 1s1, 1s2, 2s1, 2s2, 2p1. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. There's bromine. Do the off bow if you don't know how to do that. Write the actual off bow out. Let's just do it. 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. S's, P's, D's. 1, 1, 2, 2, 3. Okay, that seems like I've gone far enough. Oops. I don't want my line to get through that. I want it to go through 5S. 5S. All right. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. So I did it in the correct order. If you don't know how to do that, come see me. I don't know that you're going to get it before tomorrow, but anyway, that's it. That's how you do the review.